And thank you for the opportunity to speak here today. My name is Rune Mejer RASMUSSEN. I am a partner and executive in IBM Consulting, and I lead IBM's business within defense and intelligence in North, Central, and East Europe. So I wasn't always in consulting. The first 18 years of my career I spent in the Royal Norwegian Navy operations branch. I'm a Naval Academy graduate. And at the pinnacle of my career, I had command at sea, so I was the commanding officer of a Norwegian corvette. There is one unprecedented and transformative value coming out of the infusion of AI into military command and control systems, in particular in a multi-domain operations context, and that is the decision advantage. Just as cloud computing and AI has or are transforming consumer behaviors, productivity, and how companies are doing business, it will transform and change military doctrines as well. However, there are requirements and considerations related to using AI, in particular in military contexts, such as transparency, ethics, security, and last but not least, trust. This is complicating the implementation and realization of the decision advantage from AI in a military context. Now, because of this, IBM has made it its mission in defense and intelligence industry to solve this problem. So let's talk about decision advantage and what it is and how to make it happen. Decision advantage is you know more than the adversary, and you know before the adversary knows. And experiences, in particular from Ukraine, indicates that the value of the decision advantage is phenomenal. In many ways, it will outweigh a superior kinetic warfare capability, which is pretty unbelievable to think about. So the efforts and struggle to realize the decision advantage through the application of cloud computing and AI is more than worth it. Let's talk about a quick example, just to see if we can see the principles behind the challenge related to the realization of the decision advantage. It all starts with data. And data is coming from platforms and weapon systems across the 5 domains. So air, sea, land, cyber, and space. The data needs to be transformed into information, into knowledge, and into insights so that the commander can take informed and more precise decisions. And in order to do that, we apply AI technology in various shapes and forms. So let's do an example. Let's say that we have data coming out of a picture that was taken from a reconnaissance airplane, a P-8. That data is analyzed by a machine learning algorithm, and it concludes with what it is in the picture. And let's say it's a battle tank. So the next step in the chain is to understand if that battle tank is a friend or foe, so the make and model. Another machine learning algorithm is doing the job again and concludes it's a foe. And then you move up to the next step, which is to understand whether this battle tank is a threat or not. And in order to do that, you need data, contextual data, around the picture as such. So you need a model that has been trained on more than just sort of the hardware, if you will. And in the end, if it's concluded it is a threat, then you can make use of a large language model that is generating a tasking order for how to mitigate that threat. And the interesting thing here is that if you are using a model to generate the tasking order, you can get outcomes like, it doesn't have to be a kinetic effector that is applied to take out the threat. It could be a non-kinetic effector that you can put into an engagement to neutralize the threat. So this is sort of the chain. And what needs to happen is that the data which is coming from platforms in the various domains are not easy to get hold of. And if you have a joint strike force where you have several nations in, for example, the Navy participating, they will all have different requirements for what data they can share and to which extent, in which time window they will share it. Further to this, when it comes to the algorithms and the large language models that you apply, they also have to be governed. They have to be controlled so you are absolutely sure they're not hallucinating. And if something goes wrong, you need to be able to backtrack and find out. So it's explainable AI. So all of this is complicating the implementation of AI in the military context, and it needs to be dealt with step by step in a controlled way. So what I wanted to share with you here today is some of the reflections and the doings that we have done in this industry to resolve this problem. One of the things we did is that we tried to put together a military large language model. So it's a specific model trained on military domain, language, and doctrines. And then we trained the model on data from Janes. So we entered into a partnership with Janes that has all the OSINT, open source intelligence data, available for us to be able to train this model. That was launched earlier this year as a commercial product, and we are now doing a lot of testing of this in various tactical operational scenarios. This is an example from the Norwegian defense. Completely coincidental. The Norwegian defense has a major modernization program going on currently for acquiring fifth-generation weapon systems across all domains. There is a $90 billion budget approved by Parliament, and the military is in the process of acquiring these weapon systems. You got the P-8, anti-submarine warfare, reconnaissance plane. We just signed a contract with the UK for the Type 26 frigates. The Type 212 submarines is being built together with Germany currently, in ThyssenKrupp in Germany. We got CV-90 infantry vehicles, NASAMS 4, which also has been donated to Ukraine, the Leopard 2, F-35, and the TP-4 radars, 3D radars from Lockheed Martin. All of these super cool assets are fifth-generation weapon systems. So what does that mean? Well, that means that they come with a significant increased degree of technology sophistication as compared to the fourth generation that they're replacing. The price is 3 times higher, and the number of units is just half. So when you do a modernization like this, you end up with half the number of units and platforms, but they're 3-4 times more capable and more expensive. So what happens is that you sit on all this sophisticated technology and all these generators of data and the sensor capability of You know, the F-35 in itself is unbelievable. So what if you could harvest that data in a specific context and make it, transform it from information to knowledge to insight and then a tasking? You would have the decision advantage. In the Norwegian National Armaments Director's Office, they have concluded that you cannot put one system in between these to make it all work together. It's just not practical, it's too expensive, and it will not work. You're going to have to look at each and every one of these systems as a kill box, because that's what it is. They're designed to serve the platform. So what does that mean? It means that if you want to launch an AMRAAM from an F-35, you need to have a radar lock from the platform's radar. And getting data out of an F-35 is not easy. And in many ways, Lockheed Martin is making it difficult because it's proprietary from a weapon systems perspective. And that goes for the Leopard 2, it goes for the CV-90, it goes for the P-8, etc. So you got to find a way to extract the data in a context where you want to use it. So you can't just dump data from all of these systems into like a data swamp and then play with it. You got to look at the operational context where these systems are being used, and then get the data having a protocol that makes it secure so that you can feed the algorithms and the large language models with the AI, the data that the AI requires to produce the outcome. So what we did a project together with Lockheed Martin and the Royal Air Force. They have a unit called Rapid Capability Office in the UK, where they experiment with new technology. And together with the Skunk Works unit in Lockheed Martin in the US, we put together a solution to try to get data out of an F-35 and into a non-US based command and control system, which was kind of unheard of. This is about a year ago, we did this now. And it was an F-35 flying over Fort Worth in the US, over Lockheed Martin's test range. And we took the data from the airframe and transported it using commercial satellite link, and then download and ingest the data into a non-US command and control system in Farnborough in the UK. So by doing that, you had a real-time picture from the formidable sensors of the F-35 in the US in the command and control center in the UK, which was a big breakthrough for how this can happen. We used our branch in the UK called IBM SixWorks, which is specialists in data-centric security, and they put together a platform which is called Nexus that was put in place to make this happen. No, that was one F-35. What happens if you have multiple nations operating in a joint strike force together, which are going to contribute with data from sensors on the various platforms? Yeah? Each nation have a different policy when it comes to what data it can share, how much, and for how long. I'm not going to go into details, but the countries in NATO have very different policies on sharing of data. So you need to have a solution that can accommodate for that diversification in policy and sovereignty. Each and every platform has systems with network-related security. So it's maintenance, it's operations, it's the combat systems, and all of them are in separate networks, and the security is applied on the network. So this means that if you want to have data from one of these networks, you need to get it on a stick and then put it into another one. That's the only way to make it happen. Of course, that's not going to work in a joint strike force if you have a multi-domain operations concept going. So the solution to this, that this team that we put together in the UK, together with the Air Force, is this concept of data-centric security. So if you move the security level away from the peripheral, which is the network, and onto the data that sits inside of these networks, then you can share it based on the various policies that the various nations are upholding. So we built a design related to data-centric that we called interoperability, which is sort of architectural principles for how you can make this system of systems work in an environment where you have proprietary fifth-generation weapon systems and also multiple countries with different requirements under the sovereignty sort of perspective of it. So this architectural overview is a simplification, but it has some key sort of attributes or components to it. It starts with the zero trust security architecture, where everything is locked down. Nobody has access to anything. Then we have the principles of attribute-based access control, that's what we call it. And these attributes could be a person, it could be a device, it could be something related to environment such as a network. So you grant access based on environments, based on people, based on devices. And then you put this together in an object where all these metadata is assigned. And also the data is there as a payload. And this is then encrypted. So now all the security is around the data object. This could be track files from weapons controls radar, for example. It could be a Word document from a TechX sort of planning exercise. It could be an air tasking order, etc. So, but this is the data which is now locked in. And if you have the data payload on an object which is encrypted based on these attribute-based access controls, you can share everything in the same environment. Then you can satisfy the requirements for sovereignty that various nations have, and you can also control who gets to see the data objects or not. It's not on the network, it's on the data. So this, for us, was a breakthrough in terms of architectural designs. So again, we went together with the UK Air Force and Navy to see if we could test this out. And we did, in something called Operation High Mast. Operation High Mast was a joint carrier strike force led by the UK Royal Navy, consisting of 14 nations across NATO, that was embarking up on an 8-month mission all the way to Indo-China, projecting strength. And we put this platform that we called Pacific, which was based on the same principles that we used with the getting data out of the F-35, the Nexus platform. But no, it was focused on the Navy and the sharing of information in this joint strike carrier task force. And they've been sailing now, they're still at sea, and we have tremendous positive results coming back from this architecture. So the next thinking is, okay, how can we scale this to put it into a operational context where you have air, sea, land, space, and cyber participating in a multi-domain operations context, and we can share the data from sensors, from radars, and from tasking and planning, and also the administrative part of it. In February next year, NATO's Center for Cold Weather Warfare in Norway is going to conduct an exercise which is called Heimdall. Heimdall is an exercise where we will be focusing on testing data streams and, from unmanned aerial and underwater vehicles, and to analyze those data streams using AI to provide the decision advantage it's like a mini multi-domain operations context. So what we want to do is that we want to try out these technologies, the data-centric interoperability designs, the design from the Nexus platform and the Pacific platform from the HIMARS program, into a tactical scenario where multiple nations are participating to see if we can make this work. So the objective is the decision advantage in a multi-domain operations environment using AI to provide the insight. So this is super exciting. And what we're going to do is that we're going to put all of this technology together, bring it into the field, and then experiment with it. And what you can see here is on your right side, you will have the radio networks that connects the unmanned underwater vehicles and the drones, which is going to be flying, the autonomous systems, put it that way. And on your left side, you will see the assets that is connected to the 5G commercial network. That will be like CTR video cameras. It will be the ISR systems. The one we are using here is called VOSUS, Warfighter Sensor Observation System, which is used by the National Home Guard, and other sort of input that goes over the civilian network. Then we're going to pull the data from those sources into this system of systems architecture, having the data-centric security objects being encrypted and then shared back out into the algorithms. So we got Red Hat in here, we got IBM, we got Kongsberg Defense and Aerospace, D-Drones. So it's about 15 companies together with the military in this exercise to make this work. So this is going to happen in February, and this is something that every NATO nation can participate in as an observer, just to see how this works. And there is not a lot of these things, so I will encourage everybody to sort of think about how you can learn from this experiment. Okay, good. So getting close to the end. Some reflections related to the work that we've been doing together with our defense clients over the last couple of years in this, solving this problem of realizing the decision advantage, which is not easy. Yeah. So the first one is that high assurance engineering is required. This is not easy, and we know more about the sausages that we eat than what's inside the software that we deploy, and in particular when it comes to a military context. So a real focus on high-end engineering from a security perspective is required for everything we do in this domain. There is no one multi-domain operations AI application that you can install and then you're done. This is not how it works. You cannot have one system trying to grab data from all the various weapon systems and then have everything in a beautiful data warehouse or lake and then just pull from that. This is not how it works. You got to think about this as a system of systems. So you standardize on protocols that makes you able to extract data, encrypt it in and the security on the data side so that you can share it back into the various algorithms and large language models that needs to be using it. Designed for zero trust, data centricity, and multi-level security practices, meaning designed for a context where you have multiple nations in a joint task force with various types of policies for sharing of data. This is not the exception, it's the rule. Everything that has to do with interoperability needs to be based on open standards. You saw that we're going to sort of play around with Red Hat as the virtualization layer for the test at the Operation Heimdall in February, which is a good example of that. AI needs orchestration and it needs control. In a military context, we cannot take any risk or chance that the AI is doing what the AI wants to do. So a governance around the AI models is required. There is no way outside of that. The last one, reflection, and maybe the most important one, is how we do this. So our experience is that this is something we have to do together. We have to work in iterative processes together, industry and defense, to solve these problems. And in that process, you transfer knowledge and you build knowledge together in a team about how this works. And you have to limit the context of the problem you're trying to solve so it is solvable. And then you can take the results, apply it to a bigger context and scale. So these traditional sort of procurement methods of tenders and huge deals and years of implementation, etc., is not really working when it comes to solving these problems. Then technology, which just moved on and everything is sort of outdated when you come to the implementation. So you need to engage with industry in smaller teams to do experimentation and to solve these problems. That works. That's what we did with the Rapid Capability Office in the UK to solve this problem about getting data out of the F-35. That's what we did with the Norwegian Armed Forces when it comes to putting the Heimdall program together. And this is what we did also for the HIMAST program. It's the same way to do the Pacific platform of data centricity supporting a joint task force with multiple nations participating. So with that, I think in conclusion, I can say our experience as IBM participating in the struggle for achieving the decision advantage is that the technology is here, but the integration experience is not. And I think everything about this is the convergence towards integration. That's what we need to solve to make this happen. So with that, thank you very much, ladies and gentlemen, for your kind attention today. Enjoy the rest of the conference and be safe.